All right, let's get started, everybody. 7 o'clock, and our plan is today we're gonna be looking at some consumer arithmetic. So that was based on the poll that I had put out to you guys. You said you wanted to look at circuit theorem. We did that already. Consumer arithmetic was another one, surprisingly, and um, transformations. Hopefully, if you saw in the post that I put in the community, the plan is to do transformations Friday, hopefully. But for now, let's see what we can focus on. Right? So, consumer arithmetic and variation, that's really focused on, stuff like, when we talk about interest, wages, but I decided to put some number theory in there as well. So some fractions, some estimation, everything that you generally expect on the question one for the paper. So kind of try to mix it a little bit. So that's what we'll be focusing on for this evening. So let me list some of those so we know we're talking about these are some of the topics you'll generally see on question one. Estimation, stuff like fractions and ratios, rates and stuff like that. You'll probably see simple interest or compound, probably, whether simple or compound. And you'd also probably see, am I missing anything? Oh, stuff like wages. If you guys think I'm missing anything, you can just let me know in the chat. Some other topics that you probably would see in question one. Okay. Now, question one, I think one of the things it focuses on, one of the keys is to make sure that you can use your calculator properly. So that's one of the things that we're going to look at today. And it's very important that you have a good calculator. You should also want to make sure that you have a calculator that can do fractions. That helps to save some time as well. Right? And well, I had mine just a while ago, I don't know where it is now. But either you may make sure it's a scientific calculator, not like one of the calculators a Chinaman them use in the shop. Make sure that it's a good calculator. You can get one Jamaican dollars. I think you can get it for, I see some people get it for like 3,000. I heard somebody telling me about a calculator that was at like $500. But you can find a good one that you will use. So we're going to make sure that we're able to use that in this session as well. Right? So let's get started. So let's start with the first question. We're going to start with a little estimation. Right? Now, in this question, it's a CXC question. I didn't get the time to order them, like what year they are from, so I don't remember. But in this one, you're supposed to use a calculator to determine an exact value and then give it using some different estimations. So let's get our calculator first and foremost. So I wonder if you guys see, yeah, you see the calculator now, right? I think you should be seeing it here. Let me make it a little bigger. All right. So first, it says we want to calculate the exact value of 198 times 0.39 squared. So this is an online Desmos calculator. So I'm just going to type it in. 198 times 0.39 squared. Or you could just use the square that's beside it there. And that would be 30.1158. So that would be our answer. Alright, so I'm going to write that down. So that would, as the exact value, because the exact value means write exactly what you see on the calculator. So that is 30.1158. Alright? So just make sure that you write exactly what you see on the calculator. That's the main thing for questions like these. Okay? Is anybody not so sure about how to use the calculator, like the different stuff on it? I know that's something that it's also really important to talk about. Oh, you guys can't see my mouse right now, but look on the different stuff that I'm moving to. So, you know, you have your square root. Sometimes you'll have to use that, or your nth root. You know, that's a root. For example, if you're talking about like the cube root and the fourth root and stuff like that. You have your trig functions, and then on your calculator there's going to be a shift button, and when you press the shift button, then it should be able to do the other little I wish I had mine right beside me. Oh, think I found it, people. Yeah, this is something like this, you know. So on it, you're supposed to see the shift button. So let me get mine. Sometimes this calculator kind of catch me still, cause it's tough, you know. But yeah, so on it, like either you're going to see second or shift. I hope you're seeing it now, and you can kind of use it to get those inverse functions that you would need. As a matter of fact, in the comments, let me know, do you guys have your calculators already, or are you going to need to buy one? Don't tell me that you're one of those who use something there in class, you know, use your phone. Or tell me, if you say it go, I say it go. But do you have your calculator already? What kind of calculator you have? You can write it in the chat. Let me see. Alright. What's a bunch of say have yours already? That's good. That's pretty good. That because it's really important to have. So that's pretty good. Scientific, yes, that is what you need. So you have to have a scientific calculator. You understand? And that's good. And yeah, I'm seeing some other people saying, yeah, they got theirs. Good. So make sure you have it for this session too. Now, it says the question wants us to write our answer correct to 2 decimal places. So what does that mean? It means that we're going to go to the second decimal place for us to estimate. Okay? So it's after the decimal place. So let's look at the number. That means we're going to go 1, 2. We're going to start rounding right here. So if we look at the digit beside it, it's above, it's 5 and above. So we're going to round up. So remember, if it's from 0 to 4, round down, 5 and above, round up. So that is going to be 30.16 to 2 decimal places. All right? Now, the next one says to 3 significant figures. So you remember when we talk about significant figures, we're talking about either non-zero digits or zeros that are between non-zero digits or after the decimal point. So that's what classifies a significant figure. So we need to count and see which one of our figures are significant. So the 3 is significant because it's a non-zero digit. We have a 0 right here. Is this 0 significant or non-significant? So is it, let me know in the chats what you think. Is it significant? What say you? So would you say that one is significant? Sir, you made a mistake. Oh, yeah, that's right. Wow, guys, you guys are good. That's right, that's right. It's 30.12. Moving too quick. Yeah, thanks for the correction, guys. Good job. Thanks for spotting that error. All right. Nice. So, is the 0 there significant? What do you guys think? I'm seeing Watson saying, yeah, that 0 is significant. Good job. That's right. That 0 is significant because it's between those non-zero digits. So let's count it off now. So this one is significant, this one is significant, and the one here is significant. So this is the third significant figure. Okay? So now when we look beside it, we have a 1. So that means we're not going to round up. It's going to stay the same. So that means the 3 significant figures, I'm going to have 30.1. And so that would be the right answer. Let me ask you guys a question. What if I wanted to round it to 1 significant figure? What if I said that I wanted to round it to 1 significant figure, and then I would put that my answer is 3. Would I be correct if I said that? If I round it to 1 significant figure, what do you guys think? Yes or no? So would that be the figure rounded to 1 significant figure? Let's see what you guys are thinking. All right, good. Yeah, it would not be. And the reason why I asked that question, that is a common mistake that students make. Sometimes when they think significant figures, they just round. And they say the first significant figure, they don't business with anything else after that. But that's not the case, because remember, we have to preserve the value of the number. So as Chrisania is saying here, it would be 30. Right? So we have to make sure we preserve the value of the number. Keep that in mind, because that's a common issue that I always see. All right, finally to the nearest whole number. Reasonably, we realize that it would be 30. You know, nearest whole number, so it would be right here. And that would be our solution for this question. So that is our answer for that one. Let's go to the next question. Now this one, I think I have the number for this one. This is May 2016, and this is the first question. Now the question says, using a calculator or otherwise calculate this quotient here, giving your answer as a fraction in its lowest terms. Now remember when I tell you guys a good calculator makes all the difference? You see, because if you have a good calculator, then you can just throw all of this into your calculator directly. See? Let me show you what I mean. Because notice the question says using a calculator or otherwise. So let me take my calculator here now. So what's that? That is 3 3/8. So I'm going to put 3 and get my fraction. 3. All of it is going to be a fraction, so I'm going to put my whole fraction here. Up at the top, I'm going to have 3 3/8. What's that? Minus 2 1/4. And all of that is going to be divided by 1.5. So again, I just put that into the calculator, and it gives me 0.75. And when I change it to a fraction, it's 3/4. So a good calculator is key, because now you can just write this down straight off the bat. You understand? So that's one way that you could do it, instead of having to work it out step by step, because it says using a calculator, so you can do that as well. So this would be equal to 3/4. So make sure, I can't stress this enough, make sure that you have a good calculator. See? Now you could also work it out step by step by working them out one by one. So we could work out the 3 3/8 minus 2 1/4, and then we could divide that by 1 1/2. You want me to do that one, or you think you guys kind of get the grasp of what we're saying here? Do you know how to do that already? I want us to work it. Remember, this is all about you know. So if you're not sure on it, then let me know, because I'm here to help you. I want to make sure that you're good to go. Which calculator is the best to use? Casio is good. It just depends on the type of calculator. You understand? Just make sure that it's a scientific calculator that's easy to use. Because once it, alright, for example, when you're dealing with a fraction here, right? If you were to put this in, I know some calculators don't have it where you don't have the fraction line out like that. You see this little button? Look on your calculator. Tell me if you see this little button here. Something like that. Or you see something like that. You see that on your calculator? You see, if you see that, that represents the fraction. So what you do, another thing that you could do is that you could say, of course you have to have your brackets, because what's the problem saying? It's saying you're doing this part at the top first and then dividing it by 1 1/2. So it's gonna be, in your calculator you would write 3 3/8. So this would represent 3 3/8. And the 2 1/4, likewise you'd put in this, and this. So that would be 2 1/4. So now this is for the persons with the calculators like that. If you have a calculator like this, then you don't know what then you know what I'm talking about. If a calculator don't look like that, don't worry about it. It's just directed for them. So that's how you can put the fractions in there. Alright? And then you can work it now. For those who want us to, I see somebody say work it the long way. Alright, no problem. Let's do that. So let me rub out what I have here. And it's 3 3/8 minus 2 1/4. So now let's think about the fraction. You know that you can represent, the key is just to make sure that you can represent, or you can have your equivalent fractions, right? So 3 3/8, we can turn it into an improper fraction. So that would be 3 times 8, which is 24, plus 3, so that's 27/8. So we're working the numerator now, 27/8, minus 2 1/4, so that's 2 times 4, 8 plus 1, that's 9/4. And here, what's the LCM of 8 and 4? Okay, you know, we need to have them as equivalent fractions. So we could use 8, because 8 can go into 8, and 4 can go into 8. 8 into 8 is 1, so that's 27 times 1. And 4 into 8 is 2, so that's going to be 9 times 2. Okay, so 27 ones, that's 27. 9 times 2, that's 18. Okay, so now we are going on so far with our numerator. See? Now, 27 minus 18, what's that? We know that's 9. So that's 9/8. So this is what's in our numerator. So I should put like a little line here to show that this is the other way. Put a little R in the middle. Right? So now that means we're gonna have 9/8. Wish I had more space, but that's 9/8 divided by 1 1/2, which I can also change to an improper fraction. So as an improper fraction, 1 1/2, that's 1 times 2 plus 1, so that's 3. So that's 3/2. Okay? So this might look a little complicated. So let's break it down. What is this saying? It's saying 9/8 divided by 3/2. So I can write that out. So that's 9/8 divided by 3/2. Yeah? And now, let me come a little bit over here. We know that when we divide in fractions, what do we know? How do we divide fractions? What do you say? More, yeah, you'd have to put. I'll address that later. All right, I see that in the chat. So it would be 9/8, change the sign, times 2/3. Okay? And now we're going to have 2 into 2, 1. 2 into 8, because now we can simplify, we can cancel. 2 into 8 is 4. And then is there anything else that we can cancel? Yeah, we have the 3 and the 9. So that's 3 into 3, 1. 3 into 9 is 3. And now you realize, so you still end up with 3 times 1, which is 3, 4 times 1, which is 4. So you still end up with 3/4. You understand? So yeah, that's how you could do it. So you can work it the long way, or if you have a good calculator, put it in there. Don't afraid to do it. Makes your life like much easier. I saying if you work it without the brackets, would you be wrong? I think you're talking about with the calculator. Yes, you have to put them in the bracket. Because remember now the rule of BODMAS would apply. You have to think about what you're doing first. So you're doing what's in the numerator first. But if you just write it out like that, then the calculator is going to interpret it differently. It works by the rule of BODMAS, so it's going to do the division part first. You understand what I'm saying? So you have to put the bracket there to show that it's doing what's in the numerator, and then dividing by 1.5. I hope what I'm saying is making sense. All right. Let's go to number 2. So it says we're going to calculate this expression here. We're going to work out what we have here: 2.86 plus 0.75 in bracket plus 0.481 squared. So we just put it in the calculator straight same way. So let me get a calculator. And now, what's that? That's gonna be in bracket. Work with me now. 2.86 plus 0.75 plus 0.481 squared. So our exact answer is 3.841361. And it says we want it to 2 decimal places. So we're going to do that now to the second decimal place. So we have, I wish you guys could see my mouse, but we have here the second decimal place is at 4. Is the number beside it greater than or less than 5? It's less than, so we leave it the same way. So it would be 3.84. Alright, so let me write that here. So we know our answer is 3.841361, and we approximate it to 3.84 to 2 dp. Yeah. All right. Now it says Paul. The B question says Paul bought and sold a computer. He wrote his business activity as follows. The cost price for the computer is $1,064. The mark price of the computer is $13.99, and the discount on the mark price is 5%. First, it asks you to calculate the selling price. In other words, the paid cash. So it helps for us to think about what we're saying here. To be very careful. So he bought the computer for $1,064, right? Go into his store, put it down for $13.99 and say you can get it with a 5% discount. So the selling price, the actual amount you paid for it, would be the price less that 5%, because you're taking 5% off of the price. So think about it this way. If you take off 5% from the price, how much percentage are you going to pay for it? What's the percentage that's left? Or what's the percentage out of that mark price you are actually going to pay? Who can tell me in the comments? So you have the computer price and you take off 5%. So how much you actually going to pay for it? So that gun, how much you're going to actually pay for it? See if you guys are thinking. Oops. So you take off that 5%, right? For the whole thing. Yes, right, that's good. So you're actually paying 95%. Alright, good. So you're going to be paying 95. The actual price, your selling price is going to be equal to 95% of the price that was in the store, $1,399. And we know we can change that into a decimal, so that's 0.95 times 1,399. I don't have any space, and that's going to be equal to, let's get our handy calculator. So that's 0.95, and you could put the percentage in your calculator too, it's like either one. So 0.95 times 1,399, that is $1,329.05. Okay. So therefore, Paul, it's always good to write, sum up what you did. Paul sold the computer, but just don't itch it up here so like how I do it. Make sure you write it up nice. For $1,329.05. Alright? Alright, so we good with that one, everybody? Anybody has any questions, or that one is clear? All right, that looks like we're good. So let us look at that next one now. It says we want to find the profit or loss as a percentage of the cost price. Cool. So what is the profit? That was, first of all, is it a profit or is it a loss? Well, we know a profit if he sold it for more than he bought it. And he sold it for $1,329.05, so that would be more than what he bought it for. Okay? So you want to find the percentage profit, because the profit or loss as a percentage. So the percentage profit, to find the percentage profit, it would actually be equal to the profit over the cost price, because it says as a percentage of the cost price, times 100. Right, Akila? That is correct. So we need to find the profit. Cool? I don't know. I didn't do a lot of space here for these ones. So first, what's the profit? Now the profit would be equal to what he sold it for, the $1,329.05, minus what he bought it for, the $1,064. Right? And now, when we work that out, so we have our, $1,329.05 minus 1,064. That's $265.05. So now this $265.05 is what we're going to put over the cost price. So therefore, oh man, this is kind of, I should have the space below, you know. So therefore, the percentage profit is going to be equal to that $265.05 over the cost price, which was $1,064, times 100. And now when we put that in our calculator, so that's 265.45 divided by 1,064. And from your reaches, you can kind of know what it's going to be as a percentage. Because we know when we multiply it by 100, we get 24.91 something. So we can say 24.9% basically. Right? So that would be the percentage profit. So we can say therefore the profit is 24.9% of the cost price, or Paul made a 24.9% profit. Right? Okay, now C says orange juice is sold in cartons of 3 different sizes. So here we have the carton size, and then we have the selling price. And it asks which size of orange juice is the most cost effective buy. Justify your answer. Now, when you're thinking about problems like these, right? When you're thinking about problems like these, first we're thinking about rates, because a rate is an easy way to compare a number of stuff. So when you look at this, in order to compare it, you need to get all of them on some similar benchmark, like trying to level off all of them, get them at the same level in order to compare. And there are a lot of ways that you can do that. But remember, the main idea is that you want to get them on the same level. As a matter of fact, I have a video about Best Buy. I think I'm going to try and link it in the chat. But it discusses that a little bit more. But what I want you to know is not always the same way you do it. The key is to just get them on the same level. Alright? So one way that we can do that is to divide the carton size by the selling price. Because in that way, basically, we're going to get all of them to $1, if you get what I'm saying. So if 350 milliliters is $4.20, then I can get each of them. If I divide 350 by $4.20, I'll get the amount of milliliters per dollar. Because that's a common benchmark that all of them will have. So let's call this one A, B, and C. So now finding the milliliter or the size in milliliters per dollar. Okay. For A, the size in milliliter would be 350 milliliter divided by $4.20. Okay. So now we need to work that out. Somebody put that in the chat for me. What is that? 350 divided by 4.20. What is that? 350 divided by $4.20. Yeah, that's right. It's 83 and a third, or 83.33. So 83.33 what? Milliliters per dollar. And it's important to note that. We're going to get back to that. Remember, now we're just getting them on the same level. For B, what we have? We're going to have 450 milliliters divided by $5.35. And when I work that out, let me get my calculator too. So 450 divided by $5.35, I get 84.11. And we run it off 2 decimal place. That's safe enough based on the figures we are seeing. And then the last one now, C, 500 milliliters divided by, what's that? $5.80, I think it was. Okay, and then now that's 500 divided by $5.80. $5.80. That's 86.21 milliliters per dollar. So we know they're all on the same level. They're all talking about the amount of milliliters for your dollar. Here's a question you have to ask yourself to think about the most cost-effective buy. What do you want? If you're buying the orange juice, you're going to want more milliliters for your dollar. Therefore, the one with the highest milliliter per dollar must be the best buy. Because now you have to think about what you want, you know. Because that can help you to reason out which one going to be the answer. So that means C would be the best. Because C gives you 86.21 milliliter per dollar, more than the other two, right? So we can say, because now we have to justify, so we can say, therefore, the 500 milliliter box for $5.80 gives, is the most cost-effective buy. Alright? Because of course it gives us the most milliliters for the most orange juice for our dollar. Alright, everybody clear with that one? We're good with that? We're good to go? Any questions? Are we alright? Just want to make sure everybody is good while we're going along. Alright. So Watson say good. Alright. Oh, just seen that message, Brittany. Good night. And good night, Butterfly Girl. Who's the Butterfly Girl? I don't know. I guess I'll see eventually. Oh, let me link that video about the whole Best Buy thing as well. Because I want you guys to understand it's not the same way all the time. Just make sure that you get like, you know, you get a bit, you just want to get them at the same level. So let me put that link in the chat. Alright. Now let's go on to our next question. And now that's going to take us a little bit into some direct variation. Okay? So what is direct variation? I think that's a question we have to answer first. What is variation? Because you have direct and inverse variation. So let's make sure we get that idea before anything else. This one was one of the topics that was listed on the exam, on the broad topics. So it's one that, to be honest, even like a lot of people don't really touch it. Even myself, sometimes I don't touch it because it rarely well, it doesn't really come on the exam that often, but because they say it coming this year, we definitely want to look at it. So let me know, have you guys seen variation before? That is direct and inverse variation. Another word that it might be named is also called direct and inverse proportion. So you might know it as that name. So let me know in the chat. Have you ever seen that? I want to know before we talk about it. I want to know if I should go over it a little bit or we can jump into some problems straight. I'll give you about a minute, well, about 30 seconds to let me know. So what say you? Alright, I'm seeing one person said nope. Someone said nope. Alright, we're gonna touch on it a little bit then, because we don't want to leave out anybody. You know, just let's touch it a little just to give you an idea of what it includes or what we're talking about, right? Now, variation or proportion is a way to, it's kind of an extension of ratios, okay? Because what it does is that it compares two quantities. And you can kind of tell that from the word variation. The word variation is another word for change, okay? So basically what it does is it tells us how two things change compared to each other. For example, think about this. Suppose like you're driving to get somewhere, Zin. So you're driving to get somewhere, driving in your, yeah, that definitely look like a Benz. So you're driving to get somewhere. And of course, when you talk about distance and you talk about speed tells how fast you're going. Distance tells you, how far you're going. Then we know that if you speed up, then you can, if you're driving faster, rather, you're covering more ground. So the more you increase your speed, the more distance you cover. So that's what when we talk about a proportion. We can say that the distance is proportional to the speed. Now that type of relationship is what we call a direct variation. And we call it a direct variation because the more you speed up, the greater the more distance that you cover. So as speed increases, the distance increases. And on the other hand, if you start driving slower, you cover less distance. So as speed decreases, the distance covered also decreases. Okay? So that is what we call a direct variation. So the more you go up with the distance, then the more you go up with the speed. That makes sense? So if we were to think about it, the distance would, or one way that we can say that is that the distance is proportional to the speed. In this special case, the distance is proportional to the speed. You increase one, then you increase the other. Cool? Now in indirect variation, or variation in general, this can be translated into an equation. Because if you just leave it like this just tells us it's proportional. But then now how like you actually calculate stuff, you can create an equation for it. And it's basically saying that because as one goes up, the other goes up, there must be some constant it goes up by. So this statement can also be represented in an equation where k is a constant. So in other words, the more k is going up, k stays the same, and the more the distance goes up, the more the speed goes up. Follow me? So that's what we mean when we talk about direct variation. Now let's see if we can apply it to this problem here. And this problem is the same type of distance problem. It says the distance needed to stop a car, d, varies directly as the square of the speed, s, at which it is traveling. A car traveling at a speed of 70 kilometers per hour requires a distance of 40 meters to make a stop. What distance is required to stop a car traveling at 80 kilometers per hour? So now let's try and break down what this is saying. First of all, what do we know? What do we want to know? Sorry. We want to know the distance required to stop the car traveling at 80 kilometers per hour. So we want to know the distance. It's a value of distance that we want to know. So let's call it D. Cool? What do we already know? Tell me some things in the chat that we know based on what it says here. What do we already know? I'll give you some time to think about it. What do we know? So look at the question now. Pick out all of the things that it tell us. That, like, you know what I mean? You can figure out, say, okay, I know that information, stuff like that. What do we know? What are you guys thinking? Or you're not so sure to identify what we know? Let me hear what you guys are saying. What are some stuff? I'll give you some time to type. Okay, great. All right, seen some responses in the chat. So, Akila here is saying, we know that a car traveling at 70 kilometers per hour requires a distance of 40 meters to stop. Good. That's one thing we know. And Watson Bunch is also saying the same thing. Car traveling at 70 kilometers. So, Christian is saying we know one set of distance and speed. Good. That's very important. Right? So now, let's think about it. If we know that, and we also know we also know how they are related. What do we know? We know that D varies directly as the square of the speed, S. Right? So in other words, we know that D varies directly as the square of speed, which would be something like that. Right? And what do we know? We also, as mentioned, know that 70 kilometers per hour requires, and that speed requires a distance of 40 meters. Watch me now. We know that they are direct, they are, one varies directly as the other. So remember, square of speed, that would be speed squared, which is what we have here. If they vary directly, that means it's the same, or they go up by the same amount. So whatever ratio they are in is going to be the same all the way through. Does that make sense? So if, however, 70 compares to 40 is the same thing 80 is going to compare to anything else, its distance that is given. See? So we can think about that mathematically, because what we're saying is that D to 80 kilometers per hour squared. All right, let me write the notation first. The distance required to stop to the speed squared, that ratio, that relationship is the same throughout, is going to be the same all the way. So the one for the first one that we need is going to be the same for the other one. So we can say that that is the same. Therefore, if you require 40 meters, sorry, if you're looking for your distance for the speed squared, the distance to 80 squared, that's going to be the same of the other distance, 40 to 70 squared. That makes sense, everybody? So the ratio is the same throughout, you know. They are related the same way. So that means it must always be the same. It's kind of something like, you can kind of think about it like the sine rule. Can you remember, like the sine rule is saying the ratio is the same all the way throughout. In one way, they vary directly. So it's the same thing here. The distance varies directly with the square of the speed. So it's going to be the same all the way throughout. Because once we know that, then we can solve for our distance that we need. See? We can solve for the distance that we need. How can we do that? Well, of course, we can just make D the subject. Alright? And that means D is going to be equal to 40 times 80 squared all over 70 squared, because we multiply both sides by 80 squared. So do it by 80 squared here and 80 squared here. And now, again, as we say, once we have a good calculator, we just put that in there. So when I do that, let me get the calculator now. So we have 40, let me get the fraction, 40 times 80 squared all divided by 70 squared. And that's going to be 52.244 something. Let's call it 52.25, because 48 would be rounded to 5, and then that's the 5, so 52.25. So the distance traveled would, or the distance required to stop would be 52.2 kilometers. And let me know in the comments what you guys think about that. Are you guys with me? That's the thing. With YouTube, I can't really hear you, so like you can't open your mic and stop and ask me. But still, let me know if you are with me. And again, that's just one way how to do it. So what say you? What are you guys thinking? Are you not so sure what's going on? Talk to me now, let me know. Alright, so you're not so sure. Alright, could you run it again? Sure, of course, let's do that. So let's think about it again. So what are we saying here? We are saying that because they vary directly, so that's something to keep in mind. When they vary directly, if two quantities vary directly, their ratio is the same. Okay? So think about it this way. Let's choose a different scenario. What if we're thinking about bag juice? I don't know if you're in your country you have bag juice, but my country they sell bag juice, and bag juice is the best thing in the world. So let's say that you buy some bag juice, so you say, alright, let's say a bag juice costs $10. So we know say the cost of the bag juice is proportional to the amount that you buy. In other words, if you buy two bag juice is $20. If you buy 3 bag juice is $30. So the constant each time, so that would be 2 times 10, 3 times 10, and so on. The constant each time is 10. Right? It's always going up by 10. That's our constant value. You understand? And likewise, that means if that is the constant value, if you wanted to figure out anything else, then it would be the same constant. If you're talking about 50 bag juice, it would be the same 50 times 10. And if you're talking about, if you spend $600, then to find out how much bag juice you buy, you divide by that amount, the same 10. You understand? So, if you think about it, right? If I were to say that the cost of bag juice is 10 times the number of bag juice that I buy, then if I divide them, it would always give me back 10. It would always be the same amount. Now come up here. What we're saying is the same thing here. The distance is directly proportional to the speed, the square of the speed. So whatever the ratio they are in, for one of the quantities, it would be the same for all of them. So if it's 40 to 70 squared, it would be the same thing as D to 80 squared, and the same thing as P to 100 squared, or whatever they are. You understand? And because of that, we can figure out what the value is. So if two quantities vary directly, the ratio is always going to be the same. So that is why now we say for D, it's D to 80 squared is going to be the same thing as 40 to 70 squared. Because both of them are going to have the same ratio. It's like saying 3 to 6 is the same thing as 1 to 2. It's the same ratio. It's just that I write the ratio with the bar. So 3 to 6 is the same as 1 to 2. And 3 to 6 is the same thing as 4 to 8. The ratios are the same. So that's what I'm saying over here. 40 to 70 squared is the same thing as D to 80 squared. You get what? You see me? Let me know if that helps a little bit. Or let me know if you do it differently, because I know some people do it differently. And that's fine as well. You know, it's a little longer, but it's still fine. So once you get that concept, and this is even important too for when you're doing other stuff like the sine rule, when you're working out equivalent ratios, you can even use it in rates, like when you're doing currency and stuff like that. Once you understand that idea, that the constant is the same, the ratios are the same, that can help you to solve problems like these. Got it. All right. Good. I'm happy that that makes sense. So, in that case, that's what we're saying here. Not to belabor the point, but in that case, that's what we're saying here. Because the ratios are the same, then we can just solve for D. Right? Because we can transpose and get D by itself, throw it in the calculator, boom, bam, we're done. You understand? Yeah. Let's see if we can use it with another one, just to make sure. Because I realize the time it's an hour. Can you believe it? It's not 8 o'clock. But let's do one more. All right? Let's look at one more. Now, here in this question, it says the force F applied to an object is directly proportional to the extension E produced by that object. Represent this information as an equation in terms of F, E, and an appropriate constant K. Right? Now, you remember earlier when we talked about the equation? When we said directly proportional, we know we can come up with that one where we have that constant K. First, we need to identify what is proportional. It says F applied to an object is directly proportional to the extension E. So F is directly proportional to the extension E. In other words, the more force you apply, the more it extends. And I think my physics students know what we're talking about here. So they know which law this is. So we want to represent it as an equation. So we know that F, put that in yellow, F is proportional to k. Okay, so if f is proportional to k, that, oh sorry, not k, f is proportional to e, sorry, that means f is equal to ke, where k is the constant that you multiply e by to get f. So this would be the equation for this direct proportion. Then now it says down here, the incomplete table shows corresponding values of f and e. Using the equation obtained in CI or otherwise, determine the value of x and y. So guess what? You already know a pair of values. That's the beauty of what you have here. So in this one, you know that f, you know when f is 8, e is 0.2. And now you're going to find out what x is when f is 25. Right? So we can put that in an equation. So remember that we said if they are directly proportional, the ratios are the same. So 8, this tells us that 8, so for x, 8 to 0.2 is the same as 25 to x. Now we can solve for x, because if we cross multiply in the interest of time, that means 8x is going to be equal to 25 times 0.2. So therefore x is equal to 25 times 0.2 divided by 8. And what is that equal to? What is 25 times 0.2 divided by 8? Let's see if we can find out. So now 25 fraction 25 times 0.2 divided by 8, 0.625. So that means x in this case would be 0.625. See? No. And again, you can use the equation. This is because there are a lot. What I want you guys, what I like when students understand is that there are a lot of different ways to do it. You just use which one would work best at the time, right? So now we want when y, we have, sorry, f is y and e is 3.2. So what does that mean? We can use back the same relationship. If you want to use 60 and 1.5, you're going to get back the same thing. But let's use 8 and 0.2. So 8 to 0.2 would be equal to y to 3.2. So what can I do to get y by itself? I can multiply both sides by 3.2, right? Because if we do that, these will cancel. So that means y will be equal to 3.2 times 8 divided by 0.2. And now all we got to do is throw that into our calculator. So 3.2 times 8 divided by 0.2 is 128. So therefore y is going to be equal to 128. So those are the values of x and y. Alright? So we went a little bit over time, so we're gonna stop here still. But that is one way that we could do a problem like this, a direct variation problem, that is. So the key is just to remember the ratio is the same. Probably what I should have done is should have just done this as like one, you know. Yeah, I shouldn't have done it. I shouldn't have tried to add the consumer arithmetic and the variation. I should just do it as one thing. But either way, if anything, what we can do is we can probably look at inverse variation some other time. Right? So talk to me, guys. What about the last one? So ILPUI, oh yeah, I see you found the constant k. That's good. Yeah, you can do that. So if you solve for k, then you can put it into the equation and help you do the rest. That's another way that you can do it. But the key idea to remember, just like how you have ratios and you have rates and you have proportions, all of them is the same thing. It's just different sides of the same coin. So guess what, guys? We're gonna stop here. We're gonna stop here for tonight. Just before we stop, again, is everybody cleared what we did here? Good. Are we seeing how we could use those equations to help us? Give me a thumbs up in the chat if you are, or give me a thumbs down, or kind of confused if you're not so sure. Not so sure about that. Alright, Amoy, the next live is Friday. Next live is Friday, and we are gonna be looking at what are we looking at again? Oh, transformation, yeah. So the thing about the transformation one, I'm gonna try and do it as best as we can. I kind of like to do it like when you have the paper and stuff, but we're just gonna try to do it online as best as we can. That's why I kind of held off on that one, because I was trying to think of a good way to do it online, but can still try to do it online still gonna do it online, and we'll see what we can do. So that's gonna be the last live at 7, same time at 7. That's the last live that we're gonna have before the exam. What you guys can do in the meanwhile, I'm gonna put the playlist to all of our free workshops. Free workshop playlist for 2020, for this year. So that's what is 2022. So you can look back on those that we did already, because we did quite a few workshops. I think I see like 9 or something like that. And this would be the 10th one. So you can look through those to review any topics. If this helped, then you can like the video, because that will help other people to see it. And you can subscribe to keep updated if you're not already subscribed, So it would be good if you did that as well. So, am I missing anything? No, I don't think so. Remember, guys, study. Exam is literally 1 week away. Like, we just have 1 week leave. So make sure you study. Make sure that you practice in preparation for the next session. Spend at least an hour a day. Trust me, I'm telling you. An hour or more, hour and a half, 2 hours. Just go at it. Go hard. Because you want to make sure you pass. It's not a nice thing to have to do over maths. So make sure you do that. Alright? I know I can use polymath Amoy, but what I was talking about was, alright, like for transformations, usually I encourage my students to sneak in a piece of grease paper in there to do the rotations and to fold the paper to do the, to do the reflections and stuff like that. But we can still do it online. We make sure we try to get the best out of it. If it's not working, then I just shut off the live and say go on the yard. But for now, yeah, that I think we can do it like that. Alright, everybody, have a great week. I'll see you guys on Friday. All the best.